We've now seen how to use the calculator to find binomial probability values and how quickly and efficiently it does it, which is wonderful. But it's going to be tricky for you because you're going to have to use these phrasings to figure out which type of probability you're finding and then choose the appropriate binomial function in the calculator because you have 5 different options, lots of options. All right, so let's keep applying those. There are the calculator instructions passing by for what we've already shown. And we're going to use our infamous NBA free thrower example one more time. This should be the last time. All right, so compute the probability that exactly 2 of the players make their shots. Place the value in the table at right. Okay, so exactly 2 would be this spot right here, which if I recall we colored orange earlier because it's kind of a warning area. You got to be a little bit cautious if you're getting down there. All right, so how would that work? Well, it'd be binomial PDF because it's an exact probability. There were 3 shots taken, so that was n. Our probability of success was 0.77, and we want 2. Like that. As a matter of fact, let me put those in there. So x is 2, p is 0.77, n is 3. So we want that probability there. So I'll grab the calculator, and I'll go to distributions, letter A, and then I'll type those values, 3.772. Paste and press enter again, and you get 0.4091, which is what we said it was several pages ago. But of course, this didn't use all that work that we did in chapter 5. It just found it for us. And there we have it. All right, and when it says state the calculator entry, what it's looking for is this part right here, right? That binomial PDF, that's your work for this stuff. All right, now compute the probability that less than 2 players make their shots. Okay, so exactly 2 players make the shots is right here. Less than 2, well, that's interesting. Let me highlight that phrase there. So less than 2 means I want 0 or 1 because those are the 2 values that are less than 2. So I'm going to add them up, but I don't need to add them by hand. I mean, I could. It's 0.1344, just adding those 2 in my head. But keep in mind, we're learning a technique that'll work even if there was 30 players or 300 players. So what we're going to do is we are going to use binomial CDF. Less than 2, let me scroll back up real quickly. There it is, the table. Less than 2 means your x is 2, so you're going to use x minus 1. Like that. So that's what we're going to use. Right here. And there we'd have it. So let me see if it works. So we want binomial CDF. Oh, let me make the bigger screen for you so you can see it better. There we go. So you want binomial CDF. So you go to second distribution. You want binomial CDF, which is letter B. You're going to tell it 3 trials, 0.77. But instead of 2, you're going to put in 1 because you want it to add up 0 and 1. Basically, the calculator always starts at 0 and stops where you tell it to. So you're telling it to stop at 1. You're telling it to only add up the first 2 rows because it'll always start here and stop at whatever number you put in. So sure enough, my answer was correct. It is 1344. All right, now what about if you have to figure out your probabilities a little bit ahead of time? I mean, these ones for N and P, it was a little bit obvious because they were given to you. P is right here at 0.77. N is the fact that there's 3 players and so on. As a matter of fact, I'll highlight those. So that's where those values came from for N and P. Now, what if a student is taking a multiple choice question that has 20 questions, or multiple choice test, excuse me, that has 20 questions, and each question has 5 choices, only one of which is correct. The student's going to randomly guess. Apparently, they did not study for this test, so they're just randomly guessing answers. All right, so we need to figure out, before we can find the probability of 4, we need to figure out what N and P are. Okay, so n is kind of obvious. N is 20. You can tell n is 20 because it says 20 questions right here. So the student is guessing on 20 separate questions. So let me give that, I don't know, a green highlight right there. Now the interesting part is P. P is the probability of success. Now when you're guessing on these questions, there are 5 answers, 5 choices, excuse me, and only one of which is correct. So that means that your probability of guessing correctly would be 1 out of 5, right? So 1 out of 5. There are 5 choices, only one of which is correct. So your probability of success is 1/5. All right, now X is kind of obvious because it says 4 right there, so X is 4 for us. It's actually little x right there. X is the number of successes, and we want the probability that little x equals 4. So the way to do this is binom PDF, and then we say we're guessing on 20, comma, 0. Well, let me just type 1/5. That'll work. There we have it, comma 4. Let's see what we get. So, and I have no idea what this is. So I'm going to grab my calculator, go to distribution, and I want PDF. That's letter A. So you can see it up there. So I'm going to hit alpha A. And then I have 20 trials. The probability of success is 1/5. You can actually just type the fraction, or you can figure out the decimal. The decimal is 0.2. And then we want 4. Enter. Enter. And we get 2182. So they have a 21.8% chance of getting 4 right. And actually, I just typed up what that meant. So it's the probability of getting exactly 4 right. That's what P of 4 means. So when you see P parentheses 4, it means what's the chances of 4 successes. And there we have it. And that's 0.2182. So not great. And that's only 4 correct. Now to pass the test, the student must answer 70% or more correctly. Would it be unusual for the student to pass? Well, I'm going to guess yes, but we're going to have to figure it out how. All right, so to pass, they must receive 70% or more. So let's figure this out. We know that n is 20 and p is 0.5. That part hasn't changed. We want to pass. So that would be scoring, all right, and we need to figure out what 70% of 20 questions is or more. So let's see, 70% of 20, that'd be 0.7 times 20. That'd be 14 questions. So we need to score 14, 15, 16, all the way up to 20. So all of these would be passing. Okay, well, what we can do is we're talking about really being greater than or equal to 14. Right, everybody see this? So I just typed that up. So passing means you're scoring 70% of 20 or more. That means you're scoring 14, 15, 16, all the way up to 20. And that means your x is greater than or equal to 14. Now, I would love to write it down like that, and you should too for these problems. Kind of figure out what they're asking. And then you can go back to the table and say, okay, x is greater than or equal to 14. Greater than or equal to means I'm doing this one right here, where it's 1 minus binom CDF. And I'm going to use 13 instead of 14 because I have to do 14 take away 1. In other words, I'm going to make the calculator add up all the way to 13, and then I'm going to take it away from 1, and I'll have what 14 to 20 is. All right, so let me go back down and type that in. Oop, gone too far. There it is. Okay. So it's 1 minus binom CDF 20 comma, 0.2. Oh, let me just do 1/5 there, comma, and then we want to do 13, right? You want to do 14, take away 1. Okay, so let me grab a calculator. Binom CDF, so letter B, alpha B, it's 20.2, or if you like, you can just type 1 divided by 5. It'll figure it out. And then x value is 13, because I want it to start at 0 and add all the way up to 13. And I get 0.9999998. Wow, that's a lot of decimal places. All right, so let me type that in. And because there's so many 9s in there, I'm going to keep all of them until I get to the next number. So 5 9s and then an 8. And then I'm going to make the calculator do that subtraction. So 1 minus that answer. And then that's scientific notation. And the decimal is 6 spots over to the left. So it's 0.0050 to match the 5 9s. 1. Actually, I think it's 2 because it's 1/6 if I'm not mistaken. But 1/8, right? So 1/8, so that'll make it 2. Or if you like, you can say 1/8 here. Then just say 8/2 here, right? What a mess. You have an extremely low chance. This is very unusual, right? Because unusual for us is less than 5%. So I just typed that up. It would be very, very unusual to pass this test, this 20-question test, by randomly guessing, right? Just shows you always want to study. And that's because the probability of passing is so far below 5%. Our threshold for unusual is 5%. We learned that in chapter 3, right? And this is well below 0.05. Right? Many decimal places, many orders of magnitude actually below 0.05.